Good morning, class. Welcome to Maths Grade 11 at 9 o'clock today. I'm your presenter, Ms. Shabalala, and we are doing functions. Should you guys need to get a hold of me, please find my Twitter handle on your screen. It's _Mbaliti, _Mbaliti. Please contact me there if you've got any questions. Just throw me an inbox or a DM, and I will be sure to get back to you. So we started with functions yesterday, and we are still continuing. Welcome to everyone. Rules of engagement, just in case we have new joiners. Patience, please, from those who are not new joiners. I'm sure you know the rules by now. Please, let's respect each other. Please ask your questions. There's no such thing as a dumb question. Please raise your hand and ask, then you will be unmuted when you can ask. Please keep your cameras off. Please type your question in the chat section. If you're afraid to raise your hand, equally, you can just send me a direct message on Twitter. We'll also get back to you in that way. Don't tolerate vulgarity, guys. Please, let's respect each other. Please don't take away the opportunity to learn away from somebody else. And lastly, please subscribe to the Africa Team Geeks newsletter for updates on classes and links. Please also pass the subscription link to your friends so that they too have access to our classes. Right? So we started with the revision of functions yesterday, and I got a request from a learner who said, if you remember the structure of how I was planning to do this, we were going to revise all the functions, all the grade 10 work, and then only start the grade 11 work. But I have a learner who said to me, ma'am, why don't you start with one function, do the grade 10 revision and move into the grade 11 work? For that, then it's easier for us to follow and pick up. And so I took that advice, right? So now we're going to start with a quadratic function because we did the revision of that in yesterday's class. Hope everybody's happy with that method and appreciates that method. And that'll be a method that works better for each of you. Okay, so what are we doing in today's class? I gave you guys a homework investigation to take care of or to do, and I asked you to create a summary for me on the impact of A and Q on the graph, the parabola graph. And also what then we're jumping into today, our quadratic function, we are jumping into the effect of the parameter. The parameter is it's an additional piece of your calculation. It's a piece that you guys did not do in grade 10. So we're going to jump into that as well. Okay. Remember, guys, questions, please don't be afraid to ask. Just make good reference to your question when you do ask. Okay. So this was your homework investigation. I said to you guys, please create a summary telling me what happens to your parabola, to your quadratic graph, when you move A or when you move Q. I gave you 3 scenarios for A and 3 for Q. And I said to you guys, please create a summary for me. So what you should have found, let's start with the impact of A. What you should have found, or what you should even probably remember from last year, first and foremost, is that A cannot equal to 0. Because the moment A equals to 0, then you have a straight line and it is no longer a quadratic function, right? But nonetheless, here is my summary of what A can be. Please check it against your summary. Remember the presentation is available after the class, so I'm happy for you to take the summary as well and make it your own, right? Number 1, I said A determines the direction that the curve faces. I said it determines whether we have a smile or a frown, an upward facing or a downward facing. Remember my choice of word yesterday was think emojis, and that is what A does, okay? So when A is positive, you have a smiling face, your graph is facing upward. It is a positive mood. When A is negative, so when you have minus AX to the power of 2 plus Q, you know that your graph is negative. So your graph, when you do draw, should be a frown. It should be a negative mood, okay? The other part of this that we noted is, well, that I noted, hoping you guys noted it as well, running a few scenarios here and there, is that when A is positive, right, your graph gets narrower as A increases. Let's think about that. When A is positive, your graph gets narrower as A increases. So what I'm saying is your extensions to your left and your right come closer together towards your axis, your y-axis, when A increases. When A is negative, when you have a frown, your graph gets narrower when A decreases. So minus A to the power, minus 2A to the power, minus 2AX squared plus Q will have a wider grip than, will have a narrower grip than minus 4A squared, right? But we'll explore that as we go along. It'll begin to make sense as and when we go through functions, okay? Videos off, please, guys. Right. In summary, basically, then what am I saying about Q? Q was very simple, guys. I don't know, or did you also feel like Q was simple? Q was most of the time, so far to date, the y-intercept. It was the point at which your graph touched your y-axis, right? But what about Q was that Q affects the vertical shift of the graph. Q moves your graph up or down. So when Q is positive, your graph moves up. When Q is negative, your graph moves down, right? This goes back to speaking about turning points of minimums and maximums, but we'll talk through that as we go along, which is another, it's a principle from grade 10 functions, but obviously I'm always here for refreshers, guys. So then if you have to graph all of this, put it onto a nice summary. This is what my summary looks like. My summary comes from the Siyavula textbook, guys, the textbook that I always make reference to that you guys should use, okay? So here, first we are working with a negative A. When I said to you A is negative and it's a frown, here we have our frown, our downward facing graph. You could very well put eyes on here to make this a frown. There you go. This is our downward facing graph because A is negative. Okay. Same applies when you look at A positive. When A is positive, our graph is a smiling face. You could very well put your eyes in here because our graph is a smiling face, right? Then we're going to explore Q. When I said to you, Q shifts the graph upward or downward. I'm going to start with the point where Q is 0. Remember, so far we have found Q to be our y-intercept. We found Q to be the point at which your graph touches your y-axis. So when Q is 0, we are finding that our y-intercept sits at 0, 0, and it's right on your y-axis. Okay, then it's right on your x-axis, apologies, where y is 0. Now, when Q is positive, I said to you the graph moves up. Here is a typical example of a shift upward from your x-axis, right? This is when A is positive. Equally, when A is negative, you see you've had a shift upwards over here from your x-axis, right? So also, please guys, don't be fooled by the positioning of the graph. I could take this graph, okay, when A is negative, your graph shifts down, further away, downward from your x-axis, right? There, that's the principle. Remember guys, I could take this graph over here and say I'm shifting the graph up and still have it here. So I've shifted the graph up, but it's still below the x-axis. So please don't understand it based on being above or below the x-axis. Please understand it as moving up or moving down, where if you're moving up, your intercept, your y-intercept mostly increases, mostly. I'm very deliberate in that. And if you're moving down, the y-intercept mostly decreases. It gets more negative or just gets less positive, right? This is my summary, guys, for you for homework. And now we're going to get into today's work. We're going to spend a few days on quadratic functions before we move on to hyperbolic functions. Okay, so remember yesterday's example, guys. I gave you this parabola over here. We even tried to draw it freehand without a pen. And the formula on that was y is equal to 2x squared minus 4, right? So we worked out a few things on this parabola. Part of what we went through and discussed was domain, which was x is an element of real numbers. Remember when we were talking yesterday, I said domain speaks to what your x's are. And on this graph, your x could be absolutely any value. There is no limit on what x could be. X can never be undefined. This graph could go on for forever. And so x is an element of real numbers. Okay. Then we came to the range. When we were speaking about the range, and I was speaking to you guys about turning points, I told you about minimums and maximums. Your range speaks to your y series. How far or where in your y, on your y-axis can this number go, right? When a is positive and you have a smiling face, you have a minimum point for y. That this is the lowest that y could possibly be. From here on out, y goes up. When a is a negative and you have a frowning graph, right? Okay. And you have a frowning graph, you're talking about a maximum y, right? So this is the point at which your y begins to become less. This is the most that y could possibly be. From here on out, it could expand to the moon. It could expand to infinity. But all you know is that that is your maximum. So in this case, with our graph from yesterday, I think that, guys, y, so how I stated y was to say y is an element of real numbers because it can be any number. But the limitation on y here is y is greater than and equal to minus 4. So y starts at minus 4 and it can be anything thereafter. So that's how I denoted my range. Something imperative, guys, you do get 1 mark for writing the fact that your numbers are an element of real numbers. So please don't forget to mention that you are working with elements of real numbers. Your graph is connected, so it could possibly be any number up to infinity. After that, guys, we had x-intercepts that we calculated. If you remember, the x-intercepts are the points where y is equal to 0. And because this is a quadratic function, there are 2 of those. And we found them to be minus the square root of 2 and the positive square root of 2. Okay. Then we also got our x-intercept. Our x-intercept is the point where x was 0. Our y-intercept is where x is 0. And we found that to be 0 and minus 4. That is this point over here. Then, guys, is the turning point. The turning point is the point at which the graph reaches its, call it a peak when it's a sad graph, and call it a trough when it's a happy graph. It's the point at which the graph reaches its maximum or minimum and then begins to go back in the direction that it came from. It moves up again in the opposite direction, or it moves down again in the opposite direction. Okay, so our turning point is most of the time to date has been the lowest point on your y-axis. To date, our turning point has been the same as our our y-intercept. So our turning point is 0 and minus 4. Then, guys, there's a principle that is an old principle that was never a big deal that spoke to axes, right? This is the axis of symmetry. This is the point on your Cartesian plane or your graph where the graph the left is looking absolutely like the right. Your graph begins to mirror each side. So we know from here that our axis of symmetry is our y-axis, right? Because from the turning point, whatever we did on the left, we do on the right. It's just that now we are working with a negative x. So our axis of symmetry is the y-axis where x is equal to 0. Okay, hope that makes sense for you guys. This is what we've learned so far today, this year and last year. So now we're going to add the impact of a parameter. What happens to the graph when we have a parameter? What becomes our domain, our range, and our intercept when we have a parameter? Okay, so here we're going to investigate the impact of a parameter on a parabola. Okay, here is what the equation for a parameter, for a parabola with a parameter looking like. So it's the same thing. We have a of x plus p squared plus q. So here is the new feature. It is the p. Okay. And now we used to have two constants. We used to have a and q as our constants. Now we have three. P is also a constant. So how you would say this is a times x plus 1 or x minus 1 squared plus q. That's how you'd say it, because the p is always also a constant, right? So what we are essentially doing here is we are taking this equation, ax squared plus p. Oh, this is not a good pen. We are taking the equation ax squared plus p, and we are replacing the x with an, this should be a q, apologies guys. And we are replacing the x with a x plus p, right? That is essentially all we are doing. And all other things around q being your y-intercept, etc., all that remains unchanged. The rules as you know it around a giving you your smiley or not your smiley, all that remains unchanged. Okay, so we learned so far that a impacts whether the graph is a smile or a frown, right? We learned whether it, and that meant that your turning point has a maximum number where you have a frown, and it has a minimum point where you have a smile. Okay, that's what we've learned. We also have learned that Q is usually the y-intercept, and that Q is the turning point most of the time, right? Usually at Q, x is equal to 0, and your y is your turning point. And we found that Q drives your vertical shift, whether your graph moves up or your graph moves down. That's what we found. So now, what does P do? Right? It's simply straightforward, going to get to you and say, P determines the horizontal shift of the graph, okay? The horizontal shift of the graph. So what I'm saying to you is, it's not the right thing. What I'm saying to you is on a normal day, so far with what we've learned, our parabola sits like this. And I'm saying to you, what P does is P moves our parabola this way, or P moves our parabola that way. P shifts the graph horizontally to the left or to the right. Okay, here's an example. We're going to take yesterday's example. I'm going to erase all this. We're going to take yesterday's example. And now what we've done with yesterday's example, we have replaced the x with x plus 1. We are working with the same graph as yesterday, and we replaced x with x plus 1. So I'm going to start and say, let's fill in this is yesterday's example. Let's fill in the table, guys. Let's quickly use the table method to find all the points to be able to draw our graph, okay? So that's the graph we're going to create now is y1. Our original graph is graph y. Now we're about to create graph y1. Okay, so if we substitute x with minus 2, we have minus 2 plus 1 in the bracket, which is minus 1. And that squared gives us 1. So 2 times 1 is 2, and so it becomes 2 minus 4. 2 minus 4 gives us minus 2. Okay, so we're going to fill in our graph accordingly. Then we have, if we put in x, if we substitute minus 1 and x, that means our bracket is 0, and that means that 2 times 0 is 0. So our y is then minus 4. Same if we put in a 0, then we have a 1 squared. 2 times 1 is 2. 2 minus 4 is, oh, this is my error, guys. Let's see. So this is going to be a 0. We put in a 0, and that's 1, right? So 1 squared is 1 times 2 is 2. And then 2 minus 4 is actually 3. It's actually 2. So this, guys, is an error on my part. Apologies for that. Okay. So you fill in the graph accordingly and you move with your graph. Okay. From here, then we begin to say, oh, and then that also means, guys, my graph has a few errors. Please accept my sincere apologies for this. Okay, so that means we can also replace that with 1. Then 1 plus 1 is 2. 2 times 2 is 4. 4 times 2 is 8. And 8 minus 4 is 4. Oh, so that's correct. And when we substitute 2 in here, then we have 3. And 3 squared is 9. 9 times 2 is 18. And 18 minus 4 is 14. And that's also correct. Great. So now let's try to, so in as much as our axis doesn't go as far as 14, let's try to plot our graph where we can, right? So where x is minus 2, y is also minus 2. So we'll plot that. Where x is minus 1, y is minus 4. We'll plot that. Right. Where x is 0, y is 2. We'll plot that. And where x is 1, y is 4. So let's say our 4 would have been here, right? And our 14 would have also been pretty high up there. So then when we join our dots, our graph looks something like this. Sorry guys, I don't have a pen. So when we join our dots, our graph would look something like that. It crosses through the 2 there and it looks something like that. Okay, so we have then our graph, and we are saying this is because we have said plus 1 here. Our graph has shifted to the left, has shifted to the left. Okay, sorry guys, my left and right matters are not strong, so I have to keep saying it over and over again. Then we take our second, and so now also our axis of symmetry, our axis of symmetry has now also moved up, right? Our turning point on this graph is our lowest x, as our lowest y, which still remains 4, but is against minus 1. So our axis of symmetry has moved up to being x is equal to minus 1. This is the point at which your graph then begins to mirror. Okay. Then we take the same graph, guys, and we're going to use x minus 1 now. Okay. Now, when we use x minus 1, let me change pens. We're going to build this again. Okay. We're going to say where x is minus 2, then you have minus 2 minus 1, which is minus 3. Minus 3 squared is 9. Times 2 is 18. Minus 4 is 14. Okay. Then when you substitute with minus 1, you get a minus 2 in the bracket. When you square that, you get 4 times 2 is 8, and 8 minus 4 is 4. Put in a 0 there, and we have a minus 1. The squared is 1, which makes it 2 minus 4, which gives us a minus 2. And we do the same to complete our graph. Okay, now when our graph is complete, we're going to also plot our points on the graph. We're going to say, remember guys, my graph is not drawn to scale. Please, I'd like to highlight that my graph is not drawn to scale. Where x is minus 2, y is 14. So y is somewhere up there, right? Where x is minus 1, our y is 4. So that makes y somewhere over here. Where x is 0, y is minus 2. So that puts our graph somewhere over here. Okay. Apologies, guys. Don't know if I mentioned my dry throat from yesterday. Okay. And then where x is 1, y is minus 4. And that's right over there. Where x is 2, y is minus 2. Right over there. Okay. So if we join this graph as well, obviously it'll start from pretty far out. our graph then looks something like that. Our axis of symmetry has also now moved out. It's changed to x is equal to 1. Okay, you can see our turning point, guys, has changed. Our turning point has moved out 1. So we minused 1 here, and our graph then shifted 1 to the right. So I'm going to say to you, your shift is a minus. Your shift is equal to a minus of the turning point. You'll explore that. It will make sense as we go along, okay? But so yes, we've had a shift in our graph where even our axis of symmetry has shifted by 1 unit to the right. So when your P is negative, your graph shifts to the right. When your P is positive, your graph shifts to the left. Okay, that's pretty much the principle. So guys, this is a summary of our findings. Let's quickly complete our table. This is the original graph that we had from yesterday, and I quickly filled that in after we had done it earlier today. Okay, so I'm saying to you now, our domain on y1, let's go back to y1. y1, our domain still is an x is an element of integers, because our domain could be any real numbers, apologies, because our domain could be any number. This graph could go on and extend out for forever. There are no limits on x, and there's no point at which x is undefined. So x remains an element of real numbers, okay? Then for y, in this case, we are working with the red graph. So y reaches its max, its minimum. It's a smiling face, so we have a minimum. Y reaches its minimum here at this point, at the turning point. And at the turning point, y is equal to -4, right? So so what we know about y is the lowest that y will ever be is -4. So are you happy, guys, if I say that y is an element of -4 up to infinity? Are you guys happy for me to say that? Right? We include, this is a square bracket, right? Or you can simply write it as y is greater than and equal to -4, and y is an element of real numbers, right? Then, guys, I had to do the x-intercept. Now, this was a tricky graph. I couldn't look at the x-intercept with my eye. And then what I did is I used my formula as usual. So the equation said, or the function was, y is equal to 2 times x plus 1 squared minus 4. Okay, so what I did, guys, is then I thought, okay, we can simply go about trying to factorize this, because we're looking for the point where y is 0. When we talk x-intercept, we're looking for the point where y is 0, right? So it's 2x, 2 times x squared plus 2x plus 1. Apologies again for the writing, guys. I don't have a pen. Okay, and that comes to 2x squared plus 4x plus 2 minus 4. Simplified comes to 2x squared plus 4x minus 2. Right, guys, if this was easy to factorize, I would have easily factorized this, gotten our 2 x's in the bracket as we've always done, and those would be your intercepts, right? But because it wasn't as straightforward where you could easily factorize, what I then did was, do you guys remember the quadratic formula? I used the quadratic formula, okay? The quadratic formula simply says x is equal to b plus minus the square root of b squared minus 4ac over 2a, right? What we also know is when we name our graph, this is A this is B, and this is C. So we would substitute accordingly, okay? We would say B is 4 plus minus, and we'd say 4 squared minus 4 times 2 times minus 2, okay? Divided by 2 times 2, right? You work this out on your calculator, guys, and I found, remember, it's a plus or a minus. So the 1x is all of this plus, and the 1x is all of this minus, right? So the 1x is 4 plus the square root of 16 plus 8. So it's 32. 16 plus 16, apologies, over 4. And the other side of this thing is 4 minus the square root of 32 over 4. These are your two x's. And these are your intercepts, right? So I worked that out, and I came to a minus 2.4 and a 0, and a 0.4 and a 0. Those are my intercepts, and this is how I went about it, okay? And then the y-intercept, you take your graph and you substitute x with 0, and I came out with a minus 3 for my y-intercept. Let me go back, because I remember, guys, I made an error, so I believe it should actually be minus 2. Given the error that I had made, okay? Our turning point has shifted, guys. Our turning point has shifted by 1 to the left. Remember, it used to be that, and our turning point has shifted, but the minus 4 remains. And now our axis of symmetry is x is equal to minus 1. Okay, so we're going to do then the same thing for our y2 graph. That is the graph that we did in blue, guys. And if we remember then the graph that we did in blue, our x is also an element of real numbers. Our range is also still minus 4. The lowest y value you can have is minus 4, and it goes up. So you see, the parameter p does not affect your y's. It does not affect your minimum y or your maximum y. Your range and your domain remain unchanged, irrespective of what p is, okay? Your x-intercepts, I also did the quadratic formula method, guys, and I came out with a minus 1.8 and a 0.8, right? Minus 1.8 and 0, and a 0.8 and a 0. Please, 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 guys, please do the exercise yourself. Please investigate this, please. I actually enjoyed it, and it made a lot of things make sense, okay? Our y-intercept, however, has shifted. So now our graph is basically saying we have 2 of x minus 1 squared minus 4. And we are looking for the point where x is 0. Okay. And that is 2 minus 4. So that, oh, is it 2? Yes, it is 2. That is 2 minus 4. And that will be minus 2. So our y-intercept is now 0 and minus 2. So our y-intercept has shifted 2 units to the right, to the left. It's a minus. So our graph has shifted to the right. Yes, our graph has shifted to the right, and our y-intercept has also shifted to the right because it has gotten bigger. Okay, yes. And then our turning point has also now switched up. Our turning point was again at our axis of symmetry and has moved up as well, this way to the 1. Okay. And lastly, remember, guys, actually this question I've gotten before in my tutoring classes. Someone asked me why the y-intercept moved by 2, but everything else seemed to move by 1 because of this 2, guys. Purely, that's it. Okay. Now, axis of symmetry has changed to x is equal to 1. So you see, guys, in our findings, what we know then about our findings simply is that your P shifts your graph horizontally. So here's my new conclusions. The P has a horizontal shift. All points are moved in the same distance at the same direction. So it moves the entire graph either to the left or to the right. Okay? Right. When P is positive, your graph shifts to the left. When P is negative, your graph shifts to the right. Lastly, P also affects your turning point, right? If your P is greater than 0, when your P is positive, your turning point moves to the left of your x-axis, of your y-axis. And also the other way, your turning point moves to the right. The same is true for the opposite. Right, guys? The axis of symmetry simply becomes minus P. So remember, for y1, our P is equal to 1. So look, our axis of symmetry is minus 1. Here, our P is equal to minus 1, and our axis of symmetry is 1. That's simply it. That's what the parameter does, guys. The parameter shifts the graph to the left or to the right. I've got a homework investigation for you guys, very similar to what we've just done. We are going to take the exact same graph we've been working with. We're taking this graph, and I want you on the same set of axes, the same way I did, to please plot these three, f of x, g of x, and p of x, and then fill out the table down here, just as we have done, okay? This is the first thing we will discuss on Monday morning. Okay, I'm gonna put that up for some time. I've got about 2 minutes, guys, to make announcements. Please do get a hold of these slides so that you can do the exercise. I've got a few announcements to make, guys. This is my last day of teaching you guys. I have to go back to work. You're getting Professor Kangelani on Monday. Guys, I've never met this man physically. I've only spoken to him. What an amazing man. You guys are going to have a great time with maths with him. He's amazing, guys. Please find him. You'll meet him. He's amazing. You guys are going to have a great time with Prof. Kangelani. Thank you guys for joining me for the past month. It's really been really great. I hope I've done justice to your trigonometry and the starting point of your functions. Please remember to always enjoy maths. Do maths with your heart. Maths is a science of logic. Shouldn't be as terrible as it's made out to be. Please practice your maths. You don't study maths, you practice it. 3 sums a day. That's all you need to do, and you will begin to grasp and love maths. Okay? Those are my announcements to you guys. Okay, so this is your homework, and literally all we've done, guys, is we've just added a minus to our graphs. And then what you guys are doing on Monday, you're continuing with quadratic functions. And the first part of your homework, I'll speak to Prof. Kangelani, will be to go back and check the homework. I've attached these links for you guys to have a look. The Siyavula textbook, which speaks to the investigation we've just done today, as well as Khan Academy, where they've got a very nice video there on the impact of shifting and scaling. That's moving horizontally or moving vertically. It's a great graph that you guys please can have a look at that video. Then remember, if you've got any questions for me, if you need anything from me, hit me up on Twitter. That's my _MbayiT. And lastly, any information on the program. If you need to see your teachers' faces, guys, the pictures are there on Africa Teen Geeks. Here is all the detail, here's all the information, the hashtags and all forms of social media. Look for us, find us, chat to us, make recommendations, make requests. We are here. And that is the social media detail. So guys, have a fantastic weekend. Have a fantastic journey with Prof. Kangelani. I promise you it's going to be a fantastic journey. Keep well, guys. Best wishes to the guys that are fasting. Best wishes to all of us who are on lockdown. Remember to be kinder to each other. Remember to be safe and practice your public etiquette, your respiratory etiquette. And please take care of your hearts. Drink your water. Okay? I'm out. I am Miss Shabalala, and it was really lovely working with you guys. Cheers.